Imagine you close your eyes, that the world disappears. That sound, light, heat, everything that defines human existence suddenly evaporates, and what remains is only white. A white that is not a color, but an absence. A vast expanse so immense that even the horizon loses its meaning, because everything is the same as far as the eye can see, and far beyond. Now lower the temperature, -20, -40, -60 degrees Celsius. Not as a number, but as a sensation that passes through the fabric of clothing, the skin, the bone. A cold that does not bite but penetrates, replacing body heat with something that feels like nothingness. The silence there is not calm. It is presence. It is an entity that presses down on you. That is Antarctica before you know its truth. But there is something beyond the cold and the white. Beneath your feet, 4 kilometers deep, under layers of compact ice formed over millions of years, there are mountains no one has ever seen with their own eyes. Entire mountain ranges buried beneath the continent, as tall as the European Alps, as ancient as the first multicellular animals on Earth. There are lakes sealed since before humans existed, with liquid water that has not seen sunlight for more than 500,000 years. There is a volcano burning in the heart of the ice, with a lava lake that has bubbled endlessly since prehistoric times, defying all logic. And there are questions that the best scientists on the planet have spent decades trying to answer. What lives in that sealed water? What secrets does the oldest ice in the world hold? And what will happen when that ice, that silent giant that holds the fate of the world's coastlines, begins to collapse? This is not a tourist trip. This is an expedition to the hidden heart of the planet, to the place scientists call the last frontier of Earth, to the continent where the past, the present, and the future coexist beneath a layer of ice we have not yet learned to fully read. Welcome to Antarctica, where the silence still holds answers. To understand what makes Antarctica different from any other place on Earth, you have to stop thinking of it as a geographic destination and start thinking of it as an anomaly, an error of nature that nevertheless defines the balance of the entire planet. Antarctica covers approximately 14 million square kilometers. That is larger than Europe, larger than the continental United States. It is the 5th largest continent in the world. And yet, no one has ever lived there permanently, not once, not a single permanent human settlement in its entire history. Because Antarctica does not allow it, not because it forbids it, but because it makes it impossible. The continent receives the least precipitation on Earth, less than the Sahara. Technically, it is the largest desert in the world, but instead of sand, it has ice, and that ice holds about 90% of the planet's fresh water. If the entire Antarctic ice sheet were to melt suddenly, global sea levels would rise by roughly 60 meters. Coastal cities around the world would disappear beneath the water. London, New York, Buenos Aires, Shanghai, Tokyo, all of them. The average temperature in the interior of the continent hovers around -50 degrees Celsius in summer. In winter, in the higher regions of the plateau, it can drop to -80. The world record for the lowest temperature ever measured directly on Earth's surface was recorded at the Soviet Vostok station on July 21, 1983. -89.2 degrees Celsius, a temperature at which steel becomes brittle like glass, a temperature at which the air itself seems to shatter. To give you a sense of the scale, if we place the entire Himalayas, including Everest, beneath the Antarctic ice sheet, many of their peaks would still remain completely buried. In some places, the ice is more than 4 kilometers thick, but cold and ice are not the only extremes of this continent. Antarctic winds are the fastest on the planet on average. They are called katabatic winds, currents of icy air formed on the interior plateau, where cold, dense air descends from elevated regions toward the coast with such acceleration that gusts can exceed 300 kilometers per hour. These are not winds that blow against you. They are winds that drag you away. Winds that have buried entire expeditions under snow within hours. In winter, the continent gains territory, the surrounding ocean freezes, and Antarctica effectively doubles in size. Sea ice can extend to about 19 million square kilometers, covering the Southern Ocean hundreds of kilometers from the coast. In summer, that sea ice shrinks to between 3 and 4 million square kilometers. The continent breathes, expanding and contracting with the rhythm of the seasons like no other place on Earth. And yet Antarctica is not a dead place. It is the most alive place that almost no one has studied. The first hints that a great continent might exist in the far south appeared in ancient times. Greek philosophers, reasoning by symmetry, proposed that there must be a landmass in the southern hemisphere to balance the weight of the lands in the north. They called it the Antipodes, the opposite land. But for centuries, no one could confirm it. The pack ice surrounding Antarctica, a wall of sea ice that can stretch hundreds of kilometers beyond the coast, stopped every explorer who tried to penetrate it. Captain James Cook circumnavigated the continent between 1772 and 1775 without ever seeing it directly, sailing along the Antarctic Circle but unable to cross the ice. In his journal, Cook wrote that he had never seen anything so terrible and so sublime at the same time. Icebergs the size of cities, the green sky of the southern auroras, a cold that was not merely temperature, but presence. Years later, in 1820, the expeditions of the Russian Fabian von Bellingshausen, the British Edward Bransfield, and the American Nathaniel Palmer sighted the Antarctic coast almost simultaneously. For decades, there were disputes about who was first. Antarctica did not allow itself to be claimed easily. The first men to spend a night on the Antarctic continental land were members of the Belgian expedition aboard the Belgica in 1898, though unintentionally. Their ship became trapped in the ice during winter, and the crew, never intending to spend the polar winter, had to survive months of total darkness. Several developed scurvy, and what the expedition's doctor, the American Frederick Cook, who would later claim to have reached the North Pole, described in his diaries as polar madness, a profound disorientation, a melancholy that the cold and darkness turned into something almost physical. Antarctica, they discovered, did not only attack the body, it attacked the mind. Then came the heroic age, the period between 1895 and 1917, when the boldest explorers in the world ventured onto the ice in expeditions that today read like epics of human endurance. Robert Falcon Scott, Roald Amundsen, Ernest Shackleton, names carved into polar history because the continent tested them in ways no other place on Earth could. The race to the South Pole between Scott and Amundsen is one of the great stories of human exploration, and also one of the most revealing examples of how preparation and attitude toward the unknown determine outcomes. Amundsen reached the South Pole on December 14, 1911, using dog sleds, skis, and Arctic experience. Scott arrived on January 17, 1912, 5 weeks later, using ponies and human hauling. Amundsen returned safely. Scott and his 4 companions died on the return journey, trapped by a storm just 18 kilometers from a supply depot. Their bodies, along with Scott's diaries, were found 8 months later. The diaries were published and turned Scott into a British national hero, though historians have debated for decades whether he was a hero or a poor planner. Antarctica makes both possibilities true at the same time. Today, more than 100 years after those expeditions, Antarctica hosts 49 permanent or semi-permanent research stations operated by more than 30 countries. During the summer, between 3,000 and 5,000 scientists and support staff work there. In winter, that number drops to just over 1,000. There are no cities. There are no roads between bases. There is no way to travel across continents by land. The only way to reach Antarctica is by ship or by airplane. And both options depend entirely on the narrow weather windows that the continent itself decides sovereignly to open or close. That sovereignty of climate over human presence has not changed since Cook wrote in his journal that nature had never condemned any place to such complete sterility. What has changed is our ability to listen to what that place has to say. And what it has to say, if we learn to listen, may be the most important message the planet has ever tried to deliver. The Endurance, the shipwreck that killed no one. It is August 1914. Europe is entering war. In London, a 40-year-old man with gray eyes and a jaw that seems carved from granite reads the dispatches from the fronts while finishing preparations for an expedition that aims to change the history of exploration. His name is Ernest Henry Shackleton, and his plan is to cross Antarctica from coast to coast, a journey of approximately 2,900 kilometers across the most hostile continent on the planet, passing through the South Pole. No one had ever done it. No one would successfully attempt it again for decades. On August 8, 1914, 4 days after United Kingdom declared war on Germany, the Endurance, a 44-meter wooden ship built specifically for polar conditions, set sail from Plymouth. Shackleton had tried to place the ship at the disposal of the Royal Navy for the war effort. The response from the Admiralty was brief. The First Lord, Winston Churchill himself, sent a telegram essentially telling him to proceed with his plans. The Endurance sailed south. It stopped in Buenos Aires and then at the island of South Georgia, where Norwegian whalers operating in those waters warned Shackleton that the sea ice that year was farther north than usual, especially thick, especially treacherous. Shackleton did not listen, or perhaps he did, and decided it didn't matter. On December 5, 1914, the Endurance departed from Grytviken with 28 men aboard, scientists, sailors, a photographer, a doctor, a cook. All had answered a recruitment notice Shackleton supposedly placed in the London newspaper The Times, though historians debate whether the exact wording was as it is remembered. What is certain is its spirit. Men wanted for hazardous journey. Low wages, bitter cold, long months of complete darkness, constant danger, safe return doubtful, honor and recognition in case of success. Thousands responded. At the beginning of January 1915, the Endurance entered the Weddell Sea, and the ice the whalers had warned about was there exactly where they said it would be. Dense, compact, endless. For weeks, the ship moved slowly, breaking ice with its reinforced bow, searching for channels of open water, retreating whenever the path closed. The 28 men worked in shifts. The cold was already extreme. The Antarctic summer sun provided almost no warmth. On January 19, 1915, the Endurance became completely trapped. The pack ice closed around it like a vice. The ship could not move forward. It could not move backward. It was locked in a prison of drifting ice that slowly carried the vessel northward, away from the Antarctic coast, taking the ship and its crew in a direction no one had chosen. For 10 months, the men lived aboard the ship trapped in the ice. They organized routines. They played sports on the frozen surface. The Australian photographer Frank Hurley captured images that today are considered historical treasures. The ship illuminated by southern auroras, sled dogs playing on the white ice, the men playing hockey with the Endurance as a backdrop. There is something surreal about those photographs, something that mixes beauty with terror. On October 24, 1915, Shackleton gave the order to abandon the ship. The pressure of the ice was tearing the hull apart. Creaks echoed deep inside the wood, as if the ship itself was screaming. The men unloaded what they could: lifeboats, supplies, scientific equipment, sled dogs. Shackleton ordered the puppies euthanized because there was not enough food for all. On November 21, 1915, the Endurance sank into the Weddell Sea. The 28 men watched it disappear beneath the ice from the frozen surface. Hurley later described that moment as the quietest he had ever experienced. There were no words, only the sound of the ice. What followed is a story often described in exploration history as the greatest survival feat of all time. Shackleton and his men drifted on the ice for months. When the floes began to break apart under the austral summer warmth, they launched their 3 lifeboats into the sea and sailed for days through impossible conditions, 15-meter waves and freezing temperatures, until they reached Elephant Island. It was the first solid ground they had set foot on in 497 days. But Elephant Island had nothing. No sufficient food, no permanent shelter, no possibility of rescue. It was a bare rock in the middle of the Southern Ocean, far from any shipping route. No one would look for them there. Shackleton made the boldest decision of the entire expedition. He chose 5 men, took the largest lifeboat, the James Caird, barely 7 meters long, and sailed 1,300 kilometers across the stormiest ocean on Earth towards South Georgia, where Norwegian whaling stations were located. The journey lasted 16 days. The navigator Frank Worsley, using the stars in the brief moments when clouds parted, guided them exactly where they needed to go. They reached South Georgia in May 1916, but landed on the wrong side of the island. Between them and the whaling station at Stromness Whaling Station stood a mountain range that no one had ever crossed. Without proper climbing equipment, barely sleeping, their bodies pushed to the limit, Shackleton and 2 of his men crossed the mountains in just 36 hours. They arrived at Stromness covered in ice, their faces blackened by wind and polar sun, almost unrecognizable. On August 30th, 1916, after 4 failed rescue attempts blocked by sea ice, Shackleton finally returned to rescue the 22 men left behind on Elephant Island. He found them exactly where he had left them, all alive. Not a single person died during the entire expedition. The Endurance expedition failed in its declared objective. They never crossed Antarctica, but it proved something far more valuable. That human determination can survive conditions that, on paper, should be fatal, and that the continent that trapped them, the continent of eternal ice and absolute silence, can bend any plan, any technology, any certainty. Antarctica has its own rules, and for more than a century, it has been teaching them to us. In 2022, a scientific expedition discovered the wreck of the Endurance at the bottom of the Weddell Sea, at a depth of 3,008 meters, almost perfectly preserved by the freezing water. After 107 years, the cold had protected the ship's name on the stern, its portholes, the wood of its hull, as if the Antarctic Ocean had kept it safe, as if it had been waiting for us to return and find it. The hidden abyss, Denman Glacier, and the deepest point on Earth. On a map, Denman Glacier looks like just another one of the countless ice masses covering East Antarctica, a white blot among other white blotches. But if you could see what lies beneath that ice, if you could strip away the 4 kilometers of compact ice covering it and look down, what you would see would take your breath away. Beneath Denman Glacier lies the deepest point on land anywhere on the planet that is not covered by the ocean, a subglacial canyon descending more than 3,500 meters below sea level. To put that depth into perspective, if we stack the world's tallest building, the Burj Khalifa, 4 times on top of itself, the result would barely reach the edge of that abyss. At the base of that canyon, the Earth holds something no human has ever seen. For decades, Denman Glacier was little more than a white blot on Antarctic maps, barely a name, barely a coordinate. It was ice-penetrating radar technology mounted on aircraft and satellites over the continent starting in the 1990s that began to reveal its truth. Scientists sent pulses of radio waves downward through the ice and listened to the echoes returning from the bottom. What those echoes mapped was beyond imagination, a hidden valley of epic proportions. A rift in the Earth's crust that the ice had filled and covered for millions of years. A subglacial geometry that defies any attempt at description because there is nothing in normal human experience remotely like it. The formal discovery of Denman Canyon's true depth was published in 2019 by the University of California, Irvine, based on data from the Bed Machine Antarctica project, a decades-long effort compiling airborne radar measurements to build the most detailed map of the Antarctic bedrock ever created. The result displaced the Mariana Trench as the instinctive reference for the deepest place, because while the ocean trench is under the sea, Denman Canyon lies beneath solid land. Or what appears to be solid land. It is beneath the ice, beneath the continent, and no one had seen it until radar signal processing algorithms drew its profile on a laboratory screen in California. The depth of that canyon, 3,500 meters below sea level, covered by 4 kilometers of ice above, means that the base of the glacier is subjected to pressure and temperature conditions that geologists are still modeling. At these depths, even under solid ice, geothermal heat rising from the Earth's mantle can maintain a thin layer of liquid water between the ice and the rock. This water lubricates the glacier's movement over the bedrock, speeding it up, and the canyon, descending into the interior of the continent like a bottomless ramp, has no natural obstacle to slow that movement once it begins. But Denman's significance is not just its depth, it is the full geological context that makes it one of the most closely watched glaciers on the planet. The basin beneath the glacier has a shape glaciologists call retrograde. The bedrock slopes inland rather than upward. This means that as the glacier's front retreats toward the interior, progressively thicker ice is exposed to the ocean. More thick ice exposed means more surface in contact with relatively warm ocean water penetrating from outside. More contact with that water means more basal melting. More basal melting means the glacier flows faster toward the sea, and a faster flowing glacier exposes more ice to the ocean. It is a positive feedback loop with no visible natural breaking point. Surface velocity data of Denman, measured by synthetic aperture radar satellites over the past decades, show that the glacier is accelerating. Between 1972 and 2017, the terminus of Denman's drainage sector retreated approximately 5 kilometers in its western sector. 5 kilometers in 45 years may sound modest, but in the geometry of this particular basin, that retreat exposes the glacier to dynamics that models predict will self-amplify. If Denman Glacier were to collapse entirely, it would release enough ice to raise global sea levels by more than 1.5 meters, not immediately, but over centuries. Yet the process has already begun. Satellite measurements show cracks widening on its surface, with ice moving faster toward the ocean than in previous decades. And yet, the most fascinating thing about Denman is not the threat it poses to sea levels. It is what might lie in the depths of that canyon that no one has ever visited. At 3,500 meters below sea level, at the base of a canyon sealed beneath kilometers of ice, the conditions are unique on the planet. The pressure is immense. Darkness is absolute. Geothermal heat creates temperature gradients that could sustain chemical reactions capable of supporting life. The sediments accumulated on the canyon floor over millions of years, volcanic dust, minerals eroded from rocky walls, organic matter from eras when Antarctica still had forests, form a time archive that no drill has ever touched. The sediments at the bottom of the canyon could record the last 30 to 40 million years of the region's climate history with a resolution that ice cores cannot achieve, because ice only preserves information from the period during which it has accumulated. Rocky sediments in a closed basin can preserve signals from much older climates, and in a basin as deep as Denman, sealed and inaccessible, those sediments could remain intact. There is also the possibility of microbial life, not in the ice, where organisms found in other Antarctic glaciers are extremely scarce, but at the interface between basal meltwater and rock. In subglacial hydrothermal systems created by geothermal heat at the base of active glaciers, scientists have found chemosynthetic microbial communities that extract energy from reactions between water and rock minerals. Denman Canyon, with its extreme topography and potentially elevated geothermal heat, could be an environment where such communities exist, but reaching it is a problem that no current technology can solve. Drilling through 4 kilometers of compact ice requires logistics comparable to an oil platform, but operated in one of the most remote and inaccessible places on Earth, with weather windows that can close in hours and temperatures that destroy conventional equipment. Previous subglacial drilling projects in Vostok, Willans Lake, and Mercer Lake required years of preparation and tens of millions of dollars, and those projects drilled through 2 to 4 kilometers of relatively uniform ice. Denman Canyon lies beneath an active, moving glacier over irregular topography that would make any drilling exponentially more difficult. There is another complication that scientists discuss with a seriousness rarely shared with the general public. If life exists in the depths of Denman Canyon, even microbial life, even a community of unicellular bacteria that has evolved in isolation for millions of years, any drilling that introduces material from the surface risks irreversibly contaminating that ecosystem. The sterilization protocols applied to subglacial drilling equipment are extraordinarily strict, but no protocol can guarantee total sterility. This dilemma, explore to understand versus protect what is intact to avoid destroying it, is one of the most honest tensions in modern Antarctic science. Around the glacier, the landscape is a white void where silence becomes almost physical, something you can feel as pressure in your ears. No birds, no animals, no vegetation. Only the occasional creak of ice contracting or expanding, as if the Earth were breathing beneath its frozen prison. From space, satellites track this retreat millimeter by millimeter, month by month. The data arrives on scientists' computers as numbers and graphs, but what those numbers represent is something far older and far larger than any figure can capture. Denman Glacier reminds us that we live on a planet with its own agenda, that the scale of geological time makes human time irrelevant, and that the most important events happening on Earth right now are occurring in places we cannot see, at depths we cannot reach, in a silence our instruments barely touch. Beneath us, in the total darkness of the deepest canyon on solid Earth, something waits. Perhaps it is just rock and water and time. Perhaps it is something we still have no words to describe. The difference between these possibilities is precisely why Antarctic science continues to send planes over that endless ice, listening to the echoes returning from the depths. The Phantom Range, the Gamburtsev Mountains. There is a mountain range in the heart of Antarctica, with peaks as high as the Alps, valleys deeper than any European canyon, and a geological complexity comparable to the most studied ranges in the world. It has existed there for more than 1 billion years. No one has ever seen it with their own eyes. The Gamburtsev Mountains, named after the Soviet geophysicist Grigory Gamburtsev, who led the first radar studies confirming their existence during the International Geophysical Year of 1958, lie hidden beneath more than 4 kilometers of solid ice in the heart of East Antarctica. Their peaks do not break the surface. You cannot see even the tip of the highest summit. For all practical purposes, they are invisible. Their existence is one of the planet's greatest geological mysteries. Not because we don't know they are there, the radar and seismic measurements have mapped them with remarkable resolution, but because we still do not fully understand how they can exist. Here's the problem. Mountains form when tectonic plates collide and push the Earth's crust upward. This process creates peaks that rivers and glaciers erode over millions of years. Young ranges are high and angular. Old ranges are low and rounded. The Gamburtsevs, according to models, are over 1 billion years old. At that age, they should have been eroded almost to nothing. Yet radar shows a range with pronounced peaks, deep valleys, and a topography suggesting a youthful structure. How can a mountain range so ancient have such a young form? The explanation geologists have built over decades is that the Gamburtsevs were rejuvenated. At some point in their history, perhaps 500 to 600 million years ago, a second phase of tectonic activity uplifted the crust again in that region, and the ice, that very ice that hides them, has preserved them ever since, protecting them from the erosion that would have reduced any other range to nothing. The Gamburtsevs are, in a sense, a gift of the ice. Their invisibility is their protection. Without the ice layer burying them, they would have vanished millions of years ago. But the most intriguing hypothesis about these mountains concerns their role in the continent's history. The Gamburtsevs are believed to have been the starting point of Antarctic glaciation. Around 34 million years ago, when the planet began cooling and conditions became favorable, ice first accumulated on these peaks. From there, like an ink blot spreading on paper, the ice expanded outward, first filling valleys, then plains, and eventually covering the entire continent. If true, the mountains no one has seen gave rise to the world's largest ice sheet. They are the frozen heart of the continent. What this heart might conceal, in the words of glaciologists who study it, is incalculable. The valleys between the Gamburtsev peaks could preserve sediments from the beds of lakes and rivers that existed tens of millions of years ago, when Antarctica still had forests, rivers, and temperatures similar to present-day Europe. Scientists call these sediments the time record, layers of dust, minerals, and organic matter that document Earth's climate with precision unmatched by any other archive. In 2008, an international team of scientists under the AGAP project, Antarctica's Gamburtsev province, conducted aerial surveys over the region during 2 Antarctic seasons, deploying the most advanced ice-penetrating radar available at the time. The images they obtained were extraordinary, a complete subglacial topography with rivers of ice flowing through valleys like water, subglacial lakes nested among peaks, and structures that geologists immediately recognized but had not expected to find so intact. The surface above the Gamburtsevs is completely sterile from a visible standpoint, a white expanse without features, without marks, without anything indicating that beneath lies anything other than ice. Temperatures drop below -60 degrees. Winds have no obstacles for hundreds of kilometers. It is perhaps the most hostile place on Earth for human life. And yet, the idea that beneath this white hell lie mountains never trodden, valleys preserving records of extinct climates, lakes with water untouched by the atmosphere for millions of years, makes this place one of the most extraordinary on the planet. A sealed natural laboratory, an intact geological archive, a question posed in rock and ice that we still do not know how to read. Perhaps one day technology will allow us to drill without contaminating, descend without disturbing, see without touching. Until then, the Gamburtsevs will remain the most invisible, most inaccessible, and possibly most important mountain range on the planet. the Ellsworth Highlands, the fossilized memory of the continent. Beneath West Antarctica, where the ice is somewhat thinner than in the east but no less imposing, lies another buried mountain range. The Ellsworth subglacial mountains, detected and mapped thanks to decades of airborne radar surveys, reveal a subsurface architecture that geologists describe as remarkable even by Antarctic standards. Unlike the Gamburtsevs, whose origin is tied to very ancient tectonic processes, the Ellsworth Mountains have a more complex history. Studies published by teams from the British Antarctic Survey and the University of Cambridge indicate that these mountains may have been displaced from their original position by continental drift, rotating approximately 90 degrees over tens of millions of years. In a sense, they are mountains in the wrong place, mountains that the Earth itself moved. The orientation of the Ellsworth Mountains, aligned in a way that defies the logic of the surrounding landscape, has led scientists to reconstruct the geotectonic history of West Antarctica in ways that previously seemed impossible. And what this history reveals is that the continent we see today, that seemingly static, eternal ice mass, has actually been a deeply dynamic system, constantly reorganizing over timescales far beyond human intuition. Alongside the Ellsworth Mountains, beneath more than 3 kilometers of ice, rests Ellsworth Subglacial Lake, a body of liquid water trapped in total darkness, isolated from the atmosphere for more than 500,000 years. Geothermal heat rising from the underlying rock prevents the water from freezing despite extreme surface temperatures. It is a sealed ecosystem, a world within a world. In 2012 and 2013, an international team led by scientists from the British Antarctic Survey attempted to drill through the ice to reach the lake. The project, using hot water drilling equipment, sterilization systems to prevent contamination, and sensors designed to survive the lake's harsh conditions, represented years of preparation and millions of pounds in investment. The logistics of operating in this remote point of West Antarctica, hundreds of kilometers from any permanent base, were staggering. The project encountered technical difficulties that prevented the team from reaching the lake. The ice was more treacherous than expected. The team had to retreat without achieving their goal. It was a scientific failure, one that the researchers described with admirable honesty. Everything we could do, we did. Nature had other plans, but the significance of Ellsworth Subglacial Lake goes beyond geological interest. The lake exists under conditions that astrobiologists directly compare to the oceans that might exist beneath the ice of Europa or Enceladus, icy worlds where internal planetary heat maintains liquid water in total darkness, far from any solar energy. If we were to find life in Ellsworth Lake, even microbial life, even unicellular bacteria surviving via chemical reactions with the minerals of the rocky bed, we would demonstrate that life can emerge under such conditions. This radically changes the odds of life existing in those extraterrestrial oceans. Exploring Ellsworth Lake is not just a terrestrial scientific mission, it is a real simulation of what it will be like to search for life beyond our solar system. The cruel paradox is that the more we want to explore, the harder it becomes to do so without contaminating. The lake has remained isolated for hundreds of thousands of years. Any microorganism introduced from the surface, even inadvertently, even a single bacterium clinging to a sensor, could permanently alter this ecosystem. The sterilization protocols applied to drilling equipment are comparable to those used in the pharmaceutical industry. But Antarctic ice is not a controlled laboratory. Wind, cold, and technical contingencies create contamination vectors that cannot be completely eliminated. And so, as science develops increasingly precise tools and ever more rigorous protocols, the Ellsworth Subglacial Highlands remain there, intact, waiting. Lake Vostok, the untouched ocean. If the Gamburtsev Mountains are Antarctica's most unknown secret, Lake Vostok is its most famous mystery. More than 4 kilometers beneath the frozen surface of East Antarctica, covered by an ice dome that has formed over the last 15 million years, lies a body of water as large as Lake Ontario in North America. Nearly 250 kilometers long, 50 kilometers wide, and up to 1,000 meters deep at its lowest points. Lake Vostok has remained sealed from the outside world for over 500,000 years, perhaps much longer. Its existence was first suspected in the 1950s when the Soviet geophysicist Andrei Kapitsa, studying seismic data from the region, noticed anomalies that could not be explained by surface geology. Years later, airborne radar measurements confirmed Kapitsa's suspicions. Beneath the Vostok station, the site where the lowest temperature on Earth was recorded in 1983, there was a lake. Not a small subglacial pond, but a true inland lake, one of the largest in the world, entirely hidden beneath ice. Definitive confirmation came in the 1990s, combining European satellite radar data with Russian seismic surveys. Lake Vostok went from being a curious anomaly to one of the planet's most coveted scientific targets. Why is it so fascinating? Because the conditions beneath its surface are unique on Earth. The water is under enormous pressure, equivalent to nearly 400 atmospheres at its deepest point, and remains liquid thanks to geothermal heat rising from the bedrock, as well as the antifreeze effect of the overlying ice pressure. Paradoxically, the water temperature is below zero, around -3 degrees Celsius, yet it stays liquid. Water in a state that does not exist under normal pressure conditions. The water entering the lake does not come from rivers or rain. It comes from the melting of the ice space above, caused by geothermal heat and the pressure of the overlying ice. Once inside, this water can circulate for tens of thousands of years before refreezing at the top and being incorporated into the ice sheet. The cycle is closed. The system is hermetic. It has operated this way for hundreds of thousands of years without external disturbance. In February 2012, after more than 20 years of preliminary work and over a decade of drilling, a team from the Arctic and Antarctic Research Institute at Vostok Station finally pierced the last meter of ice separating the drill from the lake water. Participants described the moment as one of the most intense of their scientific careers. The lake water, under pressure, rose through the borehole and immediately froze upon contact with the drilling fluid. Samples of this ice, formed at the interface between the drill and the lake, were collected. Subsequent analysis of these samples revealed signs of microbial activity, not complete organisms or intact cells, but molecular markers suggesting life. The DNA detected was different from any known organism, though the possibility of surface contamination could never be completely ruled out. Science, in its honesty, acknowledges its limits. What is indisputable is this: Lake Vostok has been sealed long enough to allow evolution to follow its own path in complete isolation. If life exists there, and evidence suggests it is possible, that life has had no contact with the rest of Earth's biosphere for hundreds of thousands of years. It may have followed entirely different evolutionary trajectories, developed survival strategies unknown to us, and in the strictest sense, could be alien to anything we have studied. Vostok Station, built atop the ice covering the lake, is one of the most inhospitable places humans have inhabited. Temperatures can drop below -80 degrees Celsius. The effective altitude, given the thinner polar atmosphere, equates to being on a 4,000-meter mountain in the tropics. Winds can erase visibility in seconds, and beneath the feet of scientists working there, 4 kilometers down, a hidden ocean waits. No light, no waves, no time. A world that could hold the key to understanding where life can emerge. The fiery heart, Mount Erebus. On a continent of ice and silence, there is a place where the earth breathes fire. Rising over Ross Island in the Ross Sea, at the southern edge of the continent, its slopes are covered in snow. Its summit, over 3,794 meters high, is often shrouded in clouds of steam. But within its crater, visible from the rim if you dare to look, bubbles a permanent lava lake. One of the few truly persistent lava lakes in the world, a pool of molten rock, orange and red, that never solidifies, never rests, burning uninterrupted since prehistoric times. Mount Erebus. It was first sighted on January 27, 1841, by the expedition of Admiral James Clark Ross, sailing south in search of the magnetic pole. Ross saw 2 volcanoes along the island's coastline, one active with a column of smoke and ash visible from the sea, and one seemingly extinct. He named them after his 2 ships, Erebus and Terra. In Greek mythology, Erebus was the god of primordial darkness, the shadow that existed before the world. Terra was simply Terra. The expedition included the young surgeon Joseph Dalton Hooker, who would later become one of the most important botanists of the 19th century and a close friend of Charles Darwin. Hooker described the vision of the volcano burning amidst the ice as one of the most sublime and astonishing scenes I have ever witnessed in my life. The aesthetic contradiction of fire and ice, of hot and cold sharing an impossible landscape, was as bewildering as it was beautiful. More than 6 decades later, in 1908, during Ernest Shackleton's Nimrod expedition, a team of 4 men led by the Australian geologist Edgeworth David reached the summit of Erebus for the first time. It was the first ascent of the southernmost active volcano on Earth. David's account describes the journey as grueling: deep snow, cutting winds, and the pressure of time, since the expedition could not pause for long. When they reached the crater's edge and looked down, they were left speechless. An abyss of steam and gases with the glow of lava pulsing from the depths. Erebus is not just an active volcano in an unusual location. For geologists and astrobiologists, it is a natural laboratory of inestimable value. In the warm zones surrounding volcanic fumaroles, cracks in the rock emitting sulfurous gases at hundreds of degrees, extremophile microbial communities have thrived that exist nowhere else on the planet. These organisms do not rely on sunlight for energy. They have developed metabolisms based on the oxidation of sulfur and iron compounds, chemical processes that allow them to extract energy directly from the rock. Technically, they are chemoautotrophs, beings that feed on chemistry itself. Their significance goes beyond terrestrial biology. Conditions in Erebus's fumaroles, extreme temperatures, aggressive chemistry, darkness, and the absence of sunlight are analogous to those that might exist on other worlds, in hydrothermal vents on the ocean floor, where life independent of photosynthesis is already known, and possibly according to modern astrobiology, on planets like Mars with subsurface geothermal activity, or the icy moons of Jupiter and Saturn. Studying the microbes of Erebus is, in the most literal sense, preparing to search for life on other planets. Geologists monitoring the volcano have also found structures unlike those in any other known volcanic system. Erebus's lava tubes have unusual shapes and chemical composition. The lava expelled from the crater is phonolite, a volcanic rock with a rare chemical makeup, and the volcano's seismic behavior, its periodic eruptions, its activity cycles, the way the lava lake rises and falls, suggests a magma-feeding system that volcanologists still do not fully understand. But there is a chapter in Erebus's story that is not scientific, one that involves ice and fire in a completely different way. On November 28, 1979, a McDonnell Douglas DC-10 with 237 passengers and 20 crew members, 257 people in total, departed from Auckland Airport in Auckland at 8 a.m. Flight 901 was a scenic tourist service operated by Air New Zealand since 1977, a non-stop round trip over Antarctica with views of the ice and the volcano. A journey the airline sold as an exclusive adventure. Tickets for November 1979 cost $359 New Zealand dollars, equivalent to over $2,500 today, and they sold out. On board were New Zealand families, tourists of various nationalities, and 24 Japanese passengers. The Antarctic guide for the flight was Peter Mulgrew, an experienced explorer and personal friend of Edmund Hillary, who had originally been assigned to the flight but had to cancel due to last-minute commitments. The plane flew over the Cook Strait, crossed the Tasman Sea, entered the Southern Ocean, and finally descended over Antarctica. The pilot, Captain Jim Collins, a veteran with more than 11,000 flight hours, began descending to give passengers a better view of the landscape. The planned route was supposed to take them over McMurdo Sound between Ross Island and the continent, with side views of the volcano from a safe distance. However, the night before the flight, Air New Zealand's navigation technicians had updated the aircraft's inertial navigation system with a route correction. The change moved the DC-10's trajectory several kilometers east. Instead of flying over McMurdo Sound, the plane flew directly over Ross Island, directly toward Mount Erebus. The pilots were not informed of the change. When they departed from Auckland, they had the original flight plan in hand. The aircraft's computer had the new coordinates. Neither pilot realized the discrepancy. Over Antarctica, the plane descended through a layer of low clouds. Below, the landscape was white, always white. The optical phenomenon known as whiteout, when light diffuses between the snow-covered ground and low clouds so that contours and distances become imperceptible, made it impossible to distinguish a slope from a flat surface. Captain Collins, convinced he was on the usual route over McMurdo Sound, saw white ahead and assumed it was sea ice. It was the slope of Erebus. On November 28, 1979 at 12:49 p.m., the DC-10's terrain proximity alarm sounded. The first officer immediately increased engine power. 6 seconds later, Flight 901 struck the slope of Mount Erebus at 447 meters above sea level. The plane exploded instantly. There were no survivors. Photographs taken by passengers in the final minutes of the flight, many of which could be developed from wreckage, showed the Antarctic landscape through the windows. Some were taken seconds before impact. The initial Air New Zealand investigation concluded that pilot error caused the crash. This sparked a public outcry in New Zealand. Families demanded an independent investigation. The government appointed a royal commission led by Judge Peter Mahon. Mahon's investigation revealed the truth: the uncommunicated coordinate change, the route the plane should not have followed and no one told them about, and the whiteout that made it impossible for the pilots to identify the mountain. Mahon described Air New Zealand's defense during the inquiry as an orchestrated litany of lies. The airline went to court and managed to have that phrase removed from the official report, but the investigation itself could not be undone, nor could the truth. In 1987, a stainless steel cross was installed on the slope of Erebus on a rocky promontory 3 kilometers from the crash site. It is designated as a historic site and monument of Antarctica under the Antarctic Treaty. In 2019, 40 years after the accident, Prime Minister Jacinda Ardern issued an official apology on behalf of the government for how the airline, then state-owned, handled the aftermath. The DC-10 wreckage can still be seen on the slopes of Erebus. The ice has preserved it, as it preserves everything in Antarctica, and the volcano continues to burn unperturbed, its lava lake rising and falling, spewing anorthite and olivine crystals into the frigid air, emitting sulfurous gases that mix with ice vapor in a chemistry astrobiologists study as a model for life on other worlds. Erebus remembers nothing. Erebus simply burns. Thwaites Glacier, the Doomsday Colossus. Of all the places in Antarctica that scientists monitor closely, one stands out with a different kind of concern. It is not the explorers' worry about the unknown. It is the physician's concern for a diagnosis already known to be severe: the Thwaites Glacier. Known among glaciologists by a nickname that sounds like a sci-fi movie title, the Doomsday Glacier. Not because its collapse is imminent, but because if it occurs, the consequences would be irreversible on a human timescale. Thwaites stretches across West Antarctica, where the continent is most vulnerable because the ice rests on bedrock basins that slope inland. It covers an area comparable to half of the Iberian Peninsula. It flows toward the Amundsen Sea, where ocean currents of relatively warm water attack it from below, infiltrating cracks in the ice and corroding its foundations with a slow but deadly precision. What makes Thwaites particularly alarming is its geometry. The glacier sits on a bed that slopes inland. As the ice retreats from the seaward front, there is no natural obstacle to stop it. The slope ensures that once retreat begins, it self-amplifies. Each meter of retreat exposes more ice to the ocean. More exposed ice leads to more melting leads to more retreat. This mechanism is known as marine ice sheet instability, a tipping point from which there is no return in mathematical models. If Thwaites Glacier were to collapse entirely, global sea levels could rise more than 65 centimeters from its own ice alone. But Thwaites also acts as a plug holding back other glaciers. If that plug disappears, the glaciers behind it could accelerate toward the sea, potentially adding another 2 to 3 meters of sea level rise. In concrete terms, coastal cities worldwide, home to hundreds of millions, would be underwater or severely affected. Since 2018, an unprecedented international scientific collaboration, the International Thwaites Glacier Collaboration, ITGC, funded jointly by the National Science Foundation and the Natural Environment Research Council, has deployed human and robotic teams to the glacier each Antarctic season. More than 10 countries contribute scientists, technology, and funding. It is one of the most ambitious polar research projects ever organized. The findings have provided little reassurance. Submarine measurements taken by autonomous vehicles navigating beneath the glacier to collect data on temperature, salinity, and currents have confirmed that warm, deep ocean water penetrates far inland under the glacier more than previously believed. Subglacial caverns, some with ceilings 300 meters high, enormous bubbles of melted ice beneath the glacier's base, reveal the scale of the undercutting process. Satellite imagery shows the retreat of the glacier front year by year. Ice sliding toward the ocean has accelerated. Surface crevasses are widening. In 2021, scientists detected a fracture in the floating ice shelf that protects Thwaites, the so-called Thwaites ice shelf, with a pattern described as like a cracked windshield. If this ice shelf collapses in the coming years, the glacier will be exposed directly to the ocean. There is something deeply unsettling about the timescales climate models suggest. This is not a collapse centuries from now. Some studies published in journals such as Nature and Science indicate significant Thwaites degradation could occur within decades, not in an abstract future, but in a period many people alive today could witness. Yet Thwaites also holds unexpected secrets. In the bedrock beneath the glacier, geothermal measurements have detected unusual sources of internal heat. Some hypotheses suggest subglacial volcanic activity in this region. If geothermal heat contributes to basal melting, the situation is even more complex than current models capture. Nature, as always in Antarctica, proves more complicated than the plans we make to study it. Above Thwaites, the landscape is eerie. Kilometers-long crevasses open like black wounds on the absolute white. Ice blocks creak with sounds researchers describe as moans. The terrain seems to be disintegrating, as if the continent is shedding its own edge, delivering it piece by piece to the ocean. Thwaites Glacier is not just a threat to sea levels, it is the largest thermometer on Earth, the indicator that tells us, with the brutal precision of geology, how much we have already changed the planet's climate system. Life at the end of the world, at the most inhospitable edge of the planet, where ice covers almost the entire landscape and darkness reigns for months, one might think life is impossible. One would be wrong. Antarctica hosts one of the planet's most extraordinary ecosystems, not in spite of its extreme conditions, but because of them. The creatures that live here have not merely endured the cold, darkness, and isolation, they have been shaped by them over millions of years, until the cold and the darkness became their evolutionary advantages. The most iconic protagonist is the emperor penguin, the only bird species on Earth that reproduces during the Antarctic winter, when temperatures can drop below -60 degrees Celsius and winds can reach 150 kilometers per hour. Males incubate eggs for over 2 months without eating or leaving their colonies, protecting the eggs between their feet and under an abdominal skin pouch, while females travel hundreds of kilometers to the sea to feed. When the chicks hatch, it is at the coldest point of the year. This is not an evolutionary accident. It is a strategy refined over millions of generations to ensure offspring are ready to feed and grow when the Antarctic summer arrives. The behavior of emperors in their colonies is also one of biology's most astonishing phenomena. Males form dense clusters, sometimes thousands of individuals, that compress and rotate in a coordinated manner, without leaders or obvious signals, allowing each bird to alternate between the outer and inner parts of the mass. It is a collective survival algorithm, a distributed heating system that can keep the interior of the cluster more than 30 degrees Celsius above the outside temperature. In the waters of the Weddell Sea and Ross Sea, beneath the sea ice, Weddell seals perform feats that marine biologists still struggle to fully explain. They dive into the dark ocean to depths of up to 600 meters for more than 80 minutes, hunting under ice at -2 degrees Celsius. To breathe, they locate breathing holes in the ice, holes they maintain themselves using their progressively worn teeth, and ascend in total darkness, guided by spatial orientation systems scientists are still deciphering. Underwater, they communicate with vocalizations that, according to acoustic biologists, are among the most complex in the animal kingdom. Ice acts as a resonating chamber, propagating these sounds for kilometers. Antarctica's depths are far from silent. Orcas hunting in Antarctic waters have developed cooperative hunting techniques unlike anywhere else in the world. In the Le Maire Channel of the Antarctic Peninsula, orca groups have been observed working together to create waves that sweep penguins or resting seals off ice floes. The coordination, precision of role division, and refinement of technique over generations demonstrate true animal cultural intelligence. At the base of this ecosystem is something nearly invisible, so small it appears as greenish specks on ice or diffuse clouds in water. Antarctic krill, Eupausia superba. About 6 centimeters long, krill form swarms so dense they can be detected from space. A single swarm can contain millions of tons of krill. These swarms are the keystone of the Antarctic marine ecosystem. Whales, rorquals, penguins, seals, fish, seabirds all depend on them. They link the microscopic algae growing under the ice to the planet's largest megafauna. Krill are also among the largest biomasses on Earth. Estimates suggest total Antarctic krill biomass exceeds human biomass. Their abundance depends directly on sea ice. Krill feed on algae growing on the underside of the ice during winter. When sea ice declines, as is occurring in some Antarctic regions due to ocean warming, krill populations fall. And when krill decline, the entire ecosystem trembles. Deeper, where light never reaches, Antarctica holds other wonders. In the Ross Sea, marine biologists have found giant sponges capable of living more than 10,000 years. Not a transcription error, 10,000 years. Individuals that began growing when humans were inventing agriculture. Starfish with arms over 60 centimeters long. Nematine worms over 2 meters. Fish such as Nototheniidae that have replaced hemoglobin with alternative oxygen transport systems adapted to the coldest waters. In ice cracks, scientists have found microbial communities independent of sunlight or photosynthesis. They feed on chemical reactions between minerals and dissolved gases. They are chemolithoautotrophs, organisms extracting energy purely from chemistry. They demonstrate that life can exist without light, without solar heat, without conditions long considered essential. These organisms may be the most important life forms in Antarctica, not the most visible, not the most charismatic, but the ones that teach us most about the limits of biology. The Antarctic Treaty and the Last Frontier. In 1959, 12 countries signed an unprecedented agreement in Washington, D.C. The Antarctic Treaty declared the continent a demilitarized zone, dedicated exclusively to scientific research and free from territorial claims for the duration of the treaty. It was the first time in modern history that nations agreed an entire territory would belong to none of them. The original signatories were Argentina, Australia, Belgium, Chile, France, Japan, New Zealand, Norway, South Africa, the Soviet Union, the United Kingdom, and the United States. Today, more than 50 countries have ratified or acceded to the treaty. It has survived the Cold War, the collapse of the Soviet Union, and geopolitical tensions that have unraveled other international agreements. The Antarctic Treaty is also why Antarctica remains what it is, a continent for research, not exploitation. Beneath the ice lie substantial mineral reserves, coal, iron, copper, nickel, and potentially petroleum and natural gas on the continental shelf. The 1991 Madrid Protocol prohibits exploitation of these resources until at least 2048, when the protocol may be reviewed. What happens during that review will largely depend on what the world has learned about Antarctica by then. Scientific research on the continent continues to produce findings that reshape our understanding of the planet. The longest ice core ever drilled in Antarctica, the Epica project at Concordia Station by a European team, contains air bubbles trapped 800,000 years ago. These bubbles are direct samples of Earth's ancient atmosphere. Analysis has confirmed the correlation between atmospheric CO2 levels and global temperature with unmatched precision. Epica's data provides some of the strongest evidence for the link between CO2 and climate. Meteorites that fall on Antarctica and are preserved in ice for millennia accumulate in certain regions where ice movement concentrates them at the surface. Antarctic meteorite hunters, teams of scientists scouring blue ice fields for dark rocks contrasting with the white, have recovered tens of thousands of specimens over the decades, including fragments from Mars and the Moon. Antarctica is the largest repository of extraterrestrial samples on Earth. Then there is the ionosphere, the aurora australis, an atmospheric phenomena observable only from the poles. Telescopes at the South Pole study the cosmic microwave background, the echo of the Big Bang, with clarity unattainable from any other latitude, thanks to the polar atmosphere's extreme dryness and purity. The South Pole Telescope has contributed to some of the most important discoveries in recent cosmology. Antarctica is not just a continent, it is a scientific instrument. What the ice tells us. Antarctic ice does something with a precision that no human technology can match. It remembers. Every year, new snowfall accumulates on the continent, forming a fresh layer of ice over the previous ones. Over time, under the weight of accumulating ice, these layers compress and solidify, forming the continental ice sheet. Within them, microscopic air bubbles preserve snapshots of the atmosphere of that year. Dust particles, pollen from plants that may no longer exist, volcanic gases from eruptions across the globe, isotopes of hydrogen and oxygen in the water, which vary depending on the temperature at which the snow crystals formed. Each meter of ice core a glaciologist extracts represents 1 year, 10 years, or 100 years of Earth's climatic history, a history never written by humans, yet preserved flawlessly in the ice. The Epica ice core, drilled more than 3 kilometers deep at Concordia Station, records 800,000 years of climate history. Within that record, scientists can trace glacial cycles, periods of 100,000 to 40,000 years when ice sheets expanded over entire continents, followed by warmer intervals when ice retreated. They can detect massive volcanic eruptions that released enough material into the atmosphere to cool the planet for years. They can measure fluctuations in atmospheric CO2, which ranged between 180 and 280 parts per million over the last 800,000 years. Today, CO2 levels exceed 420 parts per million, far beyond anything the Antarctic ice has recorded in 800,000 years, an unprecedented anomaly in the planet's memory. What this means for the Thwaites Glacier, for Lake Vostok, for the ecosystems dependent on sea ice, and for emperor penguins seeking ice to rear their chicks, is a question scientists are still working to quantify. Models improve each year, data accumulate. The broad picture is clear, even if the details remain uncertain. What Antarctic ice tells us is this: we are in uncharted territory. The climate system that has governed human history is changing, and the effects will be felt first and most dramatically on the continent that acts as the planet's thermal regulator. The questions that remain. We have traversed a continent without truly setting foot on it. We have seen mountain ranges no one has ever seen, lakes that hold secrets we may not be ready to uncover, a volcano burning in the heart of ice, a glacier that could redefine the world's coastlines, ecosystems proving that life knows no bounds we can imagine. Yet there are questions that none of these stories fully answer, and that is deliberate. Antarctica is not a mystery to be solved. It is a mystery that deepens the more we explore. Is there life in Lake Vostok? If so, is it life we know or something entirely different? What would it tell us about the limits of biology if we found an organism that has evolved in total isolation for 500,000 years? Does Thwaites Glacier have a point of no return? Have we already crossed it without knowing? And if so, what does that mean for the coastal cities where hundreds of millions of people live? What lies in the depths of the Denman Glacier Canyon that has never been touched? What sediments, what organisms, what history does that abyss in total darkness hold? And what will happen when the Antarctic Treaty is reviewed in 2048? Will the world continue to choose research over exploitation? Can diplomacy protect the only continent humanity has managed to preserve as a global commons for nearly 70 years? Antarctica offers no easy answers because it is no easy place. It demands honesty. It demands admitting that we know less than we think. It demands looking at the ice and recognizing that it has been here far longer than our species, and that on the timescale that matters to the planet, our presence is just a blink. There is something deeply human in the desire to know Antarctica, in sending expeditions into the cold, in drilling through ice, in sending submersibles under glaciers. It is the same drive that led Shackleton into the Weddell Sea, ignoring warnings from whalers. The same drive that led men on the Erebus to cross mountains without climbing gear to reach Stromness. The same drive that led ITGC researchers to spend months on Thwaites, measuring a glacier that could collapse before their children are adults. We do not explore Antarctica despite the danger. We explore it because the danger is part of what makes it worth exploring. Beneath the Antarctic ice is not just rock, water, and time. It is also proof that the planet has a memory far longer than ours, and that memory preserves in its frozen layers everything we need to understand what we are doing to the future. The question is not only what is in Antarctica, the question is what we will do with what we find. Is humanity ready to listen to what the ice has to say? Every answer opens a conversation worth having. And if this journey to the planet's most mysterious continent leaves you with more questions than answers, that is precisely what it should do. The next video goes even deeper. Antarctica is not done surprising us.